So welcome to Algebra 1, High School Algebra 1. And we are beginning the very first day, so the very first lesson, and we're in Chapter 1. So at the top of your concept book, in the white area at the very top of the very first page you're using, please write Chapter 1, expressions, equations, functions, and box it up, way at the top. And then on the first line, the first blue line, we'll put the lesson name, 1.1, Evaluate Expressions. This begins on page 2 of your book. So that's why you see a number in parentheses. That's the page you could go to in the book if you wanted to read over their lesson. Okay, this is called the Algebra Concept Book because you're in algebra and we're talking about concepts of math. And in this early chapter, we're just going over some basic terms that we all need to know what they mean, their definitions. And so the first term we need to know, which is a often used term. I mean, this is algebra, so this is what we use. We use variables. Means what? What does this term mean? What would you think? How would you describe a variable if you were going to talk to a fifth grader?
A letter to represent a number.
Excellent. He said a letter to represent a number. Exactly the definition I have. Awesome. So we in algebra use letters when we have unknowns. And so those are the variables. And that's kind of what algebra is all about, using lots of variables to determine things or to represent things, okay? And equations, obviously. So an algebraic expression is one where we are, as I just said, using variables. So if the thing is this word expression, who can give me a word that talks about two expressions? I mean, we either in math we have expressions or we have this other thing. It also begins with an E. And it is when we have two expressions, we would use this other thing. Anybody? That's kind of hard to say, but yes, Ellie. No, good try though. That begins with E. She said exponent. So what if I have two expressions and they are equal? Now what can we call it? Instead of an expression, we call it an equation. Okay? So an expression is an algebraic expression, of course, is a variable expression, and it is a math sentence that does not have an equal sign. It's just a way to state something. An algebraic expression might be something like x plus 2, or just plain old x. There's a variable in it, and it represents something, but there's no equal sign. Okay, so when we're asked to evaluate an algebraic expression, we're basically finding what? The word evaluate is really important. When we see that word, we're asked to find the what? Here I have, I'm going to pause this so I can calibrate. So if I have something like 2 plus A. Can you evaluate that? Or if not, what do I need to evaluate that? Well, okay, we have a variable A, so we need to have a value for the variable, right? So give me some value. 3. So he says if A is 3, then we can evaluate that. If A is 3, what is that expression equal to? 5. So you may evaluate means to find the value, and we can do that when we know what the variable's value is, right? We substitute a value for the variable. And I usually say plug it in, plug it in. If you know what A is, you just plug it in. And then state what the value is for that expression. So in this, there's a little series of examples here. If we know that y equals 8, then for number 1, we see 7y. And I don't even see an operation. When I don't see an operation between 7 and y, the operation is? What is the operation? Addition, subtraction, multiplication, or division?
Multiplication.
Multiplication. When you don't see an operation, it's multiplication. And so 7y, when y is 8, equals 56. Good. So you can just kind of put that underneath. Again, this is not an equation, but we're going to represent the value in the simplest way possible, which is 56, rather than 7 times 8. Okay, how about y divided by 2? Y divided by 2, if you want, you could write it out. It's so basic, you probably could just state the value, and the value is 4. Good. Okay, go ahead and finish these, and I'll give you a moment to write it down. If you're at home, pause the video, do the work, and come back and check. Number 3, when you evaluate 10 minus y, your answer is?
2.
Good. And then number 4, when you evaluate y, it's not working, but y plus 6 equals?
14.
Good. So, oh, I know why, because it's frozen. There you go, it actually was working. So 14. Okay, let's talk about power. Actually, Ellie mentioned exponent when I was asking for an E word, right? And that kind of comes into play with the concept of powers. Represents something of the same factor. A power represents what of the same factor?
Multiplication.
Very good. Repeated multiplication, right? Okay, so if I have 4 to the 3rd, that is a power of 4. 4 to the 3rd. I could have 4 to the 15th. That's a power of 4 as well. And because 4 is a factor I know, we can actually evaluate that. Again, when you think of the term evaluate, it means find the what? Find the value. That's what evaluate means. Find the value of this thing. And there it is, 4 to the 3rd. We can find the value. We have to do what Aiden just said. Use repeated multiplication. So we could expand that and say 4 times 4 times 4. That's a common cube we're going to use a lot. And does anyone know right now what that is? Good, 64. So it's 16 times 4, or 64. Okay, and if you don't know it off the top of your head, you'll use it a lot and you'll learn it this year. Okay? So we should be able to read and write powers. And so how would you read this? Who could say this power? How about Olivia, since you're not able to write today, can you read it for us? Okay, so she just expanded it and told us how many 7s would be written if we were going to write it in expanded form like that. And then could you say it the way this one was said? 7 to the 5th power. So this is a power of 7, okay? So reading it, they're just simply asking you, can you read that as 7 to the 5th power, okay? In algebra, you're going to be allowed to use your calculator a lot, which is why it was on your supply list. Be sure that you have your name on the cover and the calculator in Sharpie. Okay, if anyone didn't buy one, I bought 4 over at Target that I'll sell you for the same price they are selling them for, which is $13. It's a little cheaper than later in the year. I have 4 of them, so if anybody wants them, let me know. But in the meantime, some of you who got the pack from school definitely have the right one. You don't have to have that one. You can use whatever calculator you want. It needs to be a scientific one, and it may not be Wi-Fi connectable. And so what I want you to use is a calculator that you will use a lot all the time. You want to be ready to take a standardized test with a calculator that you have been using a lot, so you're totally comfortable with it, okay? And any scientific calculator will do. The reason we suggest TI 30X2S's is because that's what the school has. And so if you use what the school has, more of us are using the same one, it kind of is easier. The nice thing about those is that you can see what you have put in because it has a 2-line screen. So that's why they're used in education. So you can actually see you wrote 2 plus 3 up there. And in some Casio and some calculators, you don't see what you wrote. You only see the last thing you wrote, right? And maybe you input something wrong, and so that's why your answer's wrong. It really was the right procedure, but you just input a number wrong, right? So that's why we go with those. you can use whatever, but please have them with you so that you can use them. 1/3, oh, how can we say this? Who can say this for us? Spencer?
1/3
To the second power. She said 1/3 to the second power. The other way to say this is 1/3 squared. So for the exponent that is 2, we sometimes will often say squared. And that's because area is a squared thing, right? Area is like you take a base times a height for a parallelogram, and that tells you how many little squares you could put in there. That's what area is. So we'll see square. And then for the third, the exponent to the third power, we would also say cube. And that's volume formulas, right? How many cubes could you fit inside of this 3D thing? And so that's why we say cube. Can anybody tell me the value of 1/3 squared? 1/3 squared is?
2/6.
So if we expand this, we would have 1/3 times what? 1/3. And so when we're multiplying fractions, we simply multiply across the top and get, and across the bottom and get 9. 3 times 3, 9, right? I know, sometimes we say 6 by accident, right? Okay, and then finally we have this most difficult term, this expression, x plus 2. So to read it, you would say, literally, you could say x plus 2 squared. Oh, actually, that's kind of wrong. This almost looks like x plus the 2 is being squared, right? So does anybody know how I could combine those two? What words can I say that would tell you you've got to combine those two first? It's like the parentheses words. You know? It begins with a Q, the Q word. Maybe it wasn't used much with you before because parentheses are a more advanced thing. But it's the, anybody want to guess, Nina? Looked like you were going to guess. It's the quantity. Okay, so the quantity x plus 2. Now that's saying, if I was going to write that, the quantity x plus 2 is in parentheses. That's a little thing on its own. And then we're going to square the whole thing. And that's what you see at the very end. The quantity x plus 2 squared. And just before well, we could talk about that tomorrow, what that value is, but we are short in time, so let's just do this. So if you're asked today in your assignment, and you're going to be asked to evaluate powers, then you are just simply going to substitute the value and simplify. Okay, so let's just do the first one on paper. Go ahead on paper, and then we'll do the others out loud. Okay, so t squared when t equals 3. Let's see if you can say the answer. I know some of you are still writing. But t squared when t equals 3. 3, 2, 1.
9.
9, right. So 3 squared is 9. Okay? And now you don't need to write these. Let's just do it together. Oh, this is tricky to do. Who thinks you might be able to do this? This is m to the 5th when m is 1/2. Think you can do it? Well, he's actually changing it to decimal form. I was thinking of it in terms of a fraction.
1/10.
Okay, well, so really it would be 1/2 to the 5th, right? So how many times do we have 1/2? We have 5 times. So we could expand this and say 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Now the numerator is going to be 1 times 1 times 1 times 1 times. What is it? 1. And now we've got to figure out 2 times 2 times 2 times 2 times 2. And who has that? 2 times 2 is
4.
And so we have 2 4s. Do you see that? 4 times 4 is 16 times 2. 32. So when you evaluate 1/2 to the 5th, you have 1/32. Okay? This one's easier. X to the 3rd. Although you might not know what x to the 3rd is, but x to the 3rd is just simply, in this case, 6 to the 3rd. And 6 to the 3rd is 36 times what? Times 6. So you might go, on your work, keep in mind you can use a little spot to scratch things out. 36 times 6, and what do you have, Cassidy?
192.
Well, 6 times 6 is 36. so you might have
Yeah, that's what I got.
216. So, that's okay, we're in a rush to finish this. This is a little hint for a question that comes up on your assignment, okay? And so what is interesting about a cube? But a cube, it has 6 sides, he says, that's true. But a cube is different than like a rectangular prism, right? Because in a cube, what can you say about every single side? I would put this down, you're going to need this in your assignment. All sides are equal. So if I tell you that this little one side right here is 2, what do I know about every single edge there?
Or 2.
They're all 2. So to find the volume of that, I would just go 2 times 2 times 2. It's 2 to the 3rd. So if you come across a problem that talks about cubes, remember, all I need is one edge, and I can find the volume. Because the volume of a cube is base area times height, or base length times width times height. Okay? So one side cubed. This is your assignment that's due Monday. So take your book home.